Okay, so we continue on, and let's give this an example. It says, evaluate the sine, cosine, and tangent of pi over 3. Again, yes, on the test in a calculus course, we would be just plugging this into our calculator. We could plug this directly into our calculator. In fact, let's just friggin' do it. Let's just do it right now. Let's plug it into our calculator to get the answers, but then I am going to show you how to do the work by hand to make sure you understand a little bit of trig. So I'm hitting sine. I'm going to hit the n over d button for the fraction. The n over d button for the fraction. I hit pi down 3. And then I hit enter, and it tells me the exact answer as root 3 over 2. Again, this is an amazing calculator. Most calculators would give us the decimal approximation of that, not the exact value, the root 3 over 2. I'll do the same thing with cosine, n over d. I hit pi down 3, enter, and it tells me that it's 1/2. And then I'm going to hit tangent, tan, n over d. I hit pi down 3, enter, and that tells me that it's the square root of 3. So those would be my answers, and that's what I would do on the calculus test. Just plug them into my calculator, but I do want to remind you how would we do this by hand. So again, pi's over 6's are closer to the x-axis, pi's over 3's are closer to the y-axis. This is a pi over 3, so I know it's closer to the y-axis. I'm just imagining if there was a triangle there. I know that the red side of the triangle is shorter than the blue side of the triangle, so I know and it's not in the middle, right? It's different sizes, so it's not in the middle. It's not a pi over 4. So I know the x value, the red value first, has to be the smaller, which is the 1/2. The y value has to be the larger, which is the root 3 over 2. I also remember that the x value is always the cosine value, and the y value is always the sine value. Okay, again, that's only because we're doing the unit circle where the radius is 1. If this was not a unit circle with the radius is 1, it would not be the x value. It would be x over r. And it would not be the y value, it would be the y over r. But we get to use the unit circle when we're just finding, remember, trigonometric functions work for any size triangle. So we might as well pick that triangle to be the unit circle, okay? The unit circle value. So here I know that cosine is 1/2, I know that sine is root 3 over 2, and then if I were to find tangent, remember, tangent's always going to be equal to the sine over the cosine value. I should be writing thetas here. I'm getting a little lazy in my notation, not writing thetas here, but that's okay. So the sine was root 3 over 2. The cosine was 1/2. If you remember, you keep, change, flip, or multiply by the reciprocal. This is root 3 over 2 times, well, flip 1/2 would be the 2 over 1. The 2's would simplify, and I'd end up with the square root of 3. So that gives me the cosine value, the sine value, and the tangent value. And if you look, that's exactly what we got on our calculator. So can you use your calculator? Yes. Should you be able to do it without your calculator? Yes as well. It says, note that these angles in this text are measured in radians unless otherwise stated. So every single time you see an angle in this textbook, you have to presume it is radian measure, not degree measure. Again, we're talking about meters versus feet, just different units. We have to presume all angles are radians in this textbook. It says the degree and radian measures of several common angles you should know in the table below, along with the corresponding values of the sine, cosine, and tangent function. So there's the degrees, there's the radians. That's what the sine is, the cosine is, and the tangent is of those values. If you want to notice that a couple of those tangent values are undefined, why would those tangent values be undefined? Well, think about it. Tangent is sine over cosine, and you can never divide by 0 with a fraction. So anywhere your cosine function is 0, your tangent function is going to be undefined. Likewise, if you looked at cotangent, anywhere sine is 0, your cotangent function would be undefined. Why did they only show these 3? Well, heck, I really only needed to see sine and cosine. I never memorized tangent, because if I know sine and cosine, I know everything. Cosecant is 1 over sine, so just flip whatever sine is. Cosine is 1 over, secant is 1 over cosine, so I just find cosine and flip it. I know tangent is sine over cosine. and then I can take cotangent, I could just flip it. So the only thing I remember is sine and cosine, and I only memorize it in the first quadrant, because if I know it in the first quadrant, all I have to do is change my x and y values from positive to negative to get into the other quadrants, and I'd be able to get all the angles. Do I even memorize this? No, I'm not gonna lie. All I do is I memorize x is cosine, y is sine, and I memorize that first quadrant in the unit circle. If I know that first quadrant in the unit circle, I know this entire chart. No need to memorize anything else. I'm able to get every single one of these values. In fact, I can get any of the angles in the entire unit circle. Okay, it says find the sine or the values of the following. Again, let's just go ahead and use our calculator for now, but I am going to show you how to do it by hand. So let's hit sine of, let's try typing in a negative, hit that N over D button, hit pi, and then down, and then 3, hit enter. I'm getting negative root 3 over 2 for the first one when I put it into my calculator. Sorry, that should be in black. Negative root 3 all over 2 is my first value. Secant of 60 degrees, this is a good one. This you cannot directly put into your calculator, but this is secant is related to cosine. So how you would put it into your calculator would be 1 over cosine of 60 degrees. So let's try that, 1, and then I hit the N over D button. Now I'm going to type in cosine of 60. Remember, if it's degrees, I have to hit that second PRB button and enter that degree symbol because I am in radian mode in my calculator. I have to put that degree symbol. So if I do 1 over cosine of 60 degrees, I'm getting a value of 2. So that's what the answer for the second one would be. If you wanted to do this using well, the unit circle is really what it comes down to. Where would negative pi over 3 be? Well, pi over 3s are closer to the y-axis. Pi over 3 would be straight down here, closer to the y-axis. Let's think about drawing that triangle. We have our red would be the short one, our x value. The red value would be the short one. The blue, the y value, would be the long one. Remember here, because I'm in quadrant 4, my x value would be positive, my y value would be negative. I know the bigger side is root 3 over 2. I know the smaller side is 1/2. The red value is our x value, so the x value would be 1/2. The y value is our larger value, so the y value here is the root 3 over 2, but again, it is negative because it's in the fourth quadrant. Remember, x is our cosine, but this problem asks for sine. Sine is our y value, so the y value there would be negative 3/2. So that's how I would have gotten that one, is just thinking about the unit circle. Where does that angle need to be? What quadrant? Which is bigger, the x or the y value? Likewise over here for 60 degrees, I know where 60 degrees is in a unit circle. That's in quadrant 1. 60 degrees is closer to the y-axis here again, so my x value would be shorter, which would be positive 1/2. My y value would be larger, which would be root 3 over 2. I know that cosine is my x value, so I'd know that since this is secant, it would be 1 over the cosine, which is 1/2. And then I would think about this as a fraction, 1 over 1 over 1 over 2. So I'd keep changing flips, so this would be 1 over 1 times 2 over 1. Right, that's the multiplied by the reciprocal, which is the value of 2. So that's how I would have gotten the secant of 60 degrees is 2. I would not have put it directly into my calculator in a trigonometric class or a trigonometry class. I would have drawn where 60 degrees is. I would have thought about my x value shorter than my y value. Here we're talking about x values because it's cosine. Cosine's 1/2. The reciprocal of that is 2, which would be the secant value.